Alright, so hi guys. So in the previous video, I went ahead and did the partial fraction decomposition for the following, integral. And the previous video was not, we hadn't gotten into doing differentiating the integral yet. So I just went ahead and did the algebra portion where I split it up into different fractions using partial fraction decomposition. So if y'all, if y'all want to watch that video, I will post a link in the description down below. But in this video, we are going to go ahead and continue with the problem, and this time we're going to actually integrate the expression and finish our problem. We're going to go ahead and rewrite the integral. So here we just had the following, and let me rewrite it here. So the integral of 8x cubed plus 13x over x squared plus 2 quantity squared dx. And so I'm going to go ahead and put this as the following. It's going to be the integral of 8x over x squared plus 2 minus 3x over x squared plus 2 quantity squared dx. Okay, so from here, we're going to go ahead and split it up into two different integrals. Now, this part, I just want to reiterate that the integral of some function f of x plus or minus g of x, let's call it g of x, so g of x, and then this entire thing dx. I just want to quickly state this is equal to the integral of f of x dx. So basically you split it up into two different integrands, or two different integrals, and then plus or minus the integral of g of x dx. Another thing is I want to go ahead and state the constant rule of integration. With constant term outside. Sorry for my handwriting, guys. Let's say we have the following. The integral of c times some function f of x dx. And so this is going to equal to the constant c times the integral of f of x dx. And this should be in blue, by the way, but, so just like that. So it's just basically meaning that we would take the constant out. So I'm just stating these two rules, guys, instead, in case we don't remember, because that is what we're going to be using for this, and we're also going to be using u substitution. So what I'm going to do is I'm going to integrate both of these expressions separately. So I'm going to say that this is equal to the integral of 8x over x squared plus 2 dx, and then minus, I think it was minus the integral of 3x over x squared plus 2 quantity squared. It should go like this. So basically we're splitting them up into two different integrals. Now, we're going to do this one first, okay? So integrate this first. So we're gonna, by u substitution. And I will post more videos over u substitution another time, probably in the next video, but yeah. So again, we're just gonna rewrite it. And I know I keep putting parentheses, but just ignore that. So this is going to equal to the following. 8 times the integral of x over x squared plus 2 dx. So we're going to say that u, and actually let me do it this way. u is equal to x squared plus 2, right? Because it needs to be canceled. When we take the derivative of u, it has to the x has to cancel out. We must have everything in terms of u. So u is x squared plus 2, and then du will be 2x dx. So the derivative of u with respect to x is 2x, right? Or du is 2x dx. Now, let's go ahead and rewrite this. So this will give us that this is going to be 8 integral of, and like I said, we're going to put in, for u, we're going to put this in here. Okay, guys? And then for du, and actually, we need to solve for dx here. So this, we have to solve for dx. Okay, so du is 2x dx. I'm sorry. Well, yeah, du is 2x dx, but we're gonna solve for dx here. So we're gonna just divide both sides by 2x to do that. And so then we end up getting that dx is du over 2x. Okay, now that's what we're gonna put in for dx. So I just want to kind of go ahead and state that very quickly. 8 integral of the following. So it's going to be x over, and remember u is on the bottom, so that we're going to put that as u. So u will be right here, and then dx will just be du over 2x. Okay, so we're just going to put in, for dx, we're going to put in du over 2x. So now you need to look very carefully. If you notice here, the x and the 2x, I'm sorry, the x and the x here and here will cancel out. Okay, guys, so here we're going to go ahead and just cancel both of these out because obviously from algebra they cancel out. This will end up giving us, it's going to be 8 integral of du over 2u, excuse me, because you're just, you're multiplying the top and the bottom. So now remember, here we want to make sure we understand that there's an invisible 1 on top. So really what this means is this is going to be 8 times the integral of 1/2 times times du over u. So this will end up giving us 8 over 2 integral of du over u. Now, here we know that 8 over 2 is 4, so we're just going to put 4 integral, and then du over u, just remember, integral of du over u is 1 over u. Integral of 1 over u du. So it's the same thing. We're just going to rewrite it that way. Now from the common integrals that we had, we want to remember that the integral of 1 over u du is really the natural log of the absolute value of u. Plus c. Okay, guys, so again, so I just want to quickly state u is equal to x squared plus 2, right? So one thing I want to state here is that I do not believe we need to put the the absolute value symbol, and I know I wrote this, there we go. So because this is always positive, right, I do not believe we need to put the absolute value. Somebody correct me if I am wrong with that, but I don't believe it's necessary. So in reality, we can go ahead and say, so because u is always positive, you do not need the absolute value symbol. So, this is going to end up being, so 4 times the integral of 1 over u. I'm sorry. So, 4 times the integral of 1 over u du will end up being 4 natural log of u, which is equal to 4. It's going to be 4 natural log of x squared plus 2. So that is what that is. And now for the next part, we're just gonna, so I will highlight that in blue because obviously that was the first part of this, right? So now the next part, we're gonna integrate just the positive integral of 3x over x squared plus 2 quantity squared dx. And then once we do all of this, we're just gonna plug it into both of the formulas. So I will do this over here, actually, if I can. So the integral of 3x over x squared plus 2 quantity squared dx is going to equal the following, and it's going to be, it is going to be, so again, we're just going to take out the 3, so 3 integral of x over x squared plus 2 quantity squared dx. And, 1 second, guys. Alright, guys. So, we're just going to integrate this. So, again, we're going to still use u substitution. So, we're going to use u substitution for both of these, really. So, again, use u substitution. U sub. So, we're going to let u equal x squared plus 2. And then again, du will be 2x dx. So it's the same idea, guys. And then finally, we're gonna solve for dx here. So this part, solve for dx. So we're just gonna say the following. So I know du is 2x dx. So then when I divide by 2 on, I'm sorry, when I divide by 2x, again, we're doing the same thing. Dx will be du over 2x. Hold on, guys. Sorry. Now put this in. Put this in. Hold on, guys. I'm sorry. Put this in for this. Okay. So, therefore, and then the u part will go in for the denominator, but you have to make sure you square it. Okay, so right here. Okay. Now so that means we're gonna have the 3 times the integral of x over u squared du over 2x. So it's gonna be 3 integral of sorry guys, oh my goodness, of x over u squared over u squared, and then du over 2x. Now, again, notice that the x's cancel out, so these two things are going to cancel out. So I just want to reiterate this. These will cancel out. Okay, guys. So here, let's see. So here we're going to have the following. Oh, sorry, guys. Give me a second. Oh, my goodness. Alright, sorry about that, guys. So, just doing some algebra here, okay, with the, multiplying, and then what you're going to do is you're going to take out the 1/2, because really there's a 1/2 here again. But make sure that you're going to take it out. You're going to say 3 over 2 integral of du over u squared. Okay. Now, for this part, I think it was, oh my goodness, isn't it negative 1 over u plus c? So, obviously this is going to equal 3 over 2 times the integral of 1 over u squared du. Now, remember from the from the integral tables, or the common integrals that we have, you can also use power rule for this if you don't remember what the integral of 1 over u squared is. If you do power rule, remember that 1 over u squared is equal to u to the negative 2, right? Because of laws of exponents. So then what you're going to do is you're going to say the following. This is the integral of u to the negative 2 du, and then using power rule, remember that the integral of u to the n du is equal to u to the n plus 1 over n plus 1, such that n does not equal negative 1. So this is going to equal to u to the negative 2 plus 1 over negative 2 plus 1, which is u to the negative 1 over negative 1, which is equal to negative 1 over u. So, I mean, that's power rule for integration. If y'all don't know how to do that, I can make a video over that, but yeah. So we want to make sure we understand a lot of previous integral rules for this, especially common integrals. So this is going to end up giving me 3 over 2 times the quantity negative 1 over u. And so finally, we're just going to substitute u back in. Well, this will be negative 3 over 2u. And so u, remember, was x squared plus 2, I think. Yeah. So u was x squared plus 2. So then we're just going to substitute. So substitute u back in. So it's going to equal negative 3 over 2 times the quantity x squared plus 2. And then for this part, I'm just going to go all the way back over here, hopefully. So basically this is our answer for this part. So all in all, we're going to have the integral of, so let's see, hold on guys, hold on. Okay guys, so I went ahead and just wrote it this way, just to save time. And finally what I'm going to do is I am going to state, so this, we have to be careful with the signs, okay? So this is the last part. So you can easily mess up with the signs. One little, if you don't watch for your signs, the positives and negatives, you're going to mess it up very quickly, or very easily. So you need to be careful. This part is going to be 4 natural log of x squared plus 2. And then we have minus, and we're going to say the following. The integral of 3x over x squared plus 2 quantity squared was negative 3/2. So negative 3 over 2 times the quantity x squared plus 2. So we're going to say minus negative 3 over 2 times the quantity x squared plus 2. And then plus our constant of integration, c. Now the last part is to finally just fix your signs here, your negative signs. So we're just going to have, this is going to equal 4 natural log of x squared plus 2 plus 3 over 2 times the quantity x squared plus 2, and then plus our constant of integration, c. And this equals, this is our final answer for the for the integral of the following, which was the integral of 8x cubed plus 13x. Sorry guys, hold on. Over x squared plus 2 quantity squared. Quantity squared dx. So this, guys, is our final answer. You can distribute the 2 on the bottom, but you don't have to. But that is our final answer for this problem, guys. It was very, very difficult. I do apologize if it took me this long, but yeah, these problems are intense. So with that being said, guys, that is going to be it for this video. Thank you so much for watching, and I do apologize for the little errors, for my technical errors. But with that being said, guys, thank you so much for watching, and please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.